Hi, third period and seventh period. We're going to be working on graphing parabolas, quadratic functions, from the three main forms: standard form, vertex form, which we learned yesterday, and factored form. So let's start with standard form. Before break, we learned that standard form was in the form of ax squared plus bx plus c. For the function f of x equals negative x squared plus 2x plus 3, my a is negative 1, my b is 2, and my c is 3. So right off the bat, I do know that my y-intercept is going to be at 0, 3. That's really the only thing that standard form tells me when I look at it. I guess the other thing we could say is we do know my parabola is going to point down because my a is negative. So how do we graph it? Well, we need to find a vertex. And I can't see the vertex as I can in vertex form, which we learned yesterday. So there's a really nice equation that's super important. It's the equation for the axis of symmetry, or the x-coordinate of the vertex. That equation is x equals negative b over 2a. So for this problem, the x-coordinate of my vertex would be negative 2 divided by 2 times a, which is negative 1. This would be negative 2 divided by negative 2, or 1. The x-coordinate of my vertex is 1. So I know the x-coordinate of my vertex is 1. My axis of symmetry, sometimes called the AOS, is also going to be x equals 1, x equals 1, and I'll talk more about that after my parabola is drawn. So now that we have the vertex, if we want to know the y value, we're going to just plug the x value back into the function to find my y. So up here, if I want to find y, I'm going to find f of 1. So it's negative, and then the only part being squared is just the x. So it's just the 1 being squared. This is not negative 1 squared. This is just a negative in front of 1 squared. Plus 2 times 1 plus 3. So this problem gives me a negative 1 plus 2 plus 3, or a 4. So my y value would be 4. So let's go ahead and plot my vertex, 1, 4. And that would be the vertex of my parabola. Yesterday we learned that our movements were the quadratic numbers 1, 1, 2, 4. And in this case, since my parabola points down, technically I'm moving 1, negative 1, and 2, negative 4. My movements in the y direction will be down. So let's start at my vertex and go 1 to the right, 1 down, 1 to the left, 1 down. Let's go back to my vertex and go 2 to the right and down 4. 1, 2, 3, 4. And then let's go 2 to the left, 1, 2, and down 4. 1, 2, 3, 4. And now we have 5 points and we can draw in our parabola. So we'll just draw in our parabola, putting arrows on the end because our parabola continues forever. And then this would be my parabola drawn. Let's talk about that axis of symmetry for a moment, this x equals 1. This is the vertical line that divides my parabola in half. It goes through my vertex. And we learned earlier this year that vertical lines have the equation x equals. This is the line x equals 1. X equals 1 is my axis of symmetry as well as the x-coordinate of my vertex. The only question to answer here is my y-intercept, which I know from my form, my y-intercept was 3. So I know my y-intercept is 0, 3. I also drew through it, so I can actually see it on my graph too. So this is how you would graph the standard form. You have to use this new equation, x equals negative b over 2a. Let's practice that one more time before we go on to our other forms. If you could flip to your second page, you have a quadratic function in standard form. Only I don't want to use this function. It has some decimal values or fractional values in the vertex, and I don't want to graph those at this time with you guys. So can you change it to y equals x squared plus 6x plus 8? So my first step is to figure out what my x-coordinate of my vertex is. So x equals negative b divided by 2a. And in this problem, my a is 1, my b is 6, and my c is 8. So I know that that would be negative 6 over 2 times 1, or negative 3. The x-coordinate of my vertex is negative 3, and my axis of symmetry is x equals negative 3. So let's find out what my y value is. So I'm going to plug a negative 3 in for x. This is the negative 3 being squared, because that's what x is. Plus 6 times negative 3 plus 8. This equals 9 minus 18 plus 8. So in this case, it looks like my problem will be a negative 1. I'm sorry, my y value will be a negative 1. So this would give me negative 3, negative 1 for my vertex. So let's go plot that. So I have negative 3, negative 1. In this problem, my a is a positive 1. This graph then will point up. So I'm going to use my movements, my 1, 1, 2, 4, and I will be going up when I do my y values. So 1 to the up 1, 1 to the left, up 1. Go back to your vertex, 2 to the right, up 4, 1, 2, 3, 4. And 2 to the left, 1, 2, up 4, 1, 2, 3, 4. And then I will use these 5 points to sketch in my parabola. And I'll put arrows on the end, these arrows going up because my a was positive. So I also have an axis of symmetry going through this one. Again, my axis of symmetry is a vertical line at x equals negative 3. So in this problem, I also know that my y-intercept would be at 8. It's not currently on my graph. If I wanted to put it on my graph, I could, and then I could extend this up so that it went through that point as well. So you need 5 points to graph your parabola for me, and that would be the vertex, the 4 on either side of the vertex. So now let's talk about vertex form, which we were first introduced to yesterday. So this is my vertex form. We're going to look at an a that's not 1 when we do this problem. However, everything that you're going to graph on your own, I believe the a is either 1 or negative 1. I don't believe you're going to have any problems you're going to encounter right now where your a is not 1. So in this problem, I know my a is 2. I know that my h is negative 3. Got to think the opposite. And I know my k is negative 1. So this actually tells me my vertex. This is why we call this vertex form, because I can literally look at it and just say my vertex is negative 3, negative 1, done. So this problem, it's negative 3, negative 1. I then also know my axis of symmetry. That vertical line that goes through my parabola will occur at x equals negative 3. It will go through the x-coordinate of my vertex, but we'll see that in just a moment. So I'm going to go to my graph, and I'm going to graph negative 3, negative 1. So this time, though, my movements are not going to be 1, 1, 2, 4. So this is my movement when my a is 1, or if it's negative 1 and I move downwards. If my a is 2, if my a is 2, my x movements are still 1 and 2, but my y movements have to double because my a is double. So actually for this problem, I'm going to go to the left and right 1, but I'll be going up 2 because my a is positive. There's no negative in front of my a, and so I know then that I will be going up. And then instead of going up 4, I'm going to double that because my a is 2. I'm doubling it, so I'm going to go up 8. That's what happens if your a is something besides 1. It changes your vertical movement by whatever that number is. If that had been a 3, I would have multiplied my 1 and 4 by a 3. And so in this problem, when I go over 1, instead of going up 1, I'm going to go over 1 and up 2. And then I'm going to go left 1 and also up 2. And I'm going to come back to my vertex and go over 2, and instead of going up 4, I'm actually going to be going up 8, which is off my graph. So, or no, actually I think it's just the last one on my graph. 1, 2, 3, 4, 5, 6, 7, 8. Perfect. Just at the tippy top there. And then let's go to the left 2 and also go up 8. So you can see how this graph is a little skinnier. It's more narrow. My A is something greater than 1. It's 2. And it's just made my y values increase faster. And so that makes my parabola more narrow than it would have been otherwise. That's what the A equals 2 is doing to my problem. So then you can see your axis of symmetry in here, that line that splits my parabola in half, and that occurs at x equals -3. Okay, ladies and gentlemen, there's one more form, factored form. We've briefly talked about graphing with factored form in class, but we haven't really done much with it. So I want to take a look at this particular problem. We know how to find our x-intercepts. So in this case, my A is 1. You could still have an A out in front. We have looked at problems where there was a negative out in front. That would be when it would point down. So on this problem, I know my x-intercepts are at 4 and 2. Because if I put a positive 4 in here, I would get a 0. If I put a positive 2 here, I'd get a 0. That's what my x-intercepts do. It's kind of hard to see on these doodle pages, but this is saying x equals p and x equals q, meaning it's equal to 4 and 2. So my zeros, or my x-intercepts, occur at 4, 0 and at 2, 0. So what do I do with that? Well, you need to find the coordinate of your vertex. The x-coordinate of your vertex will always be in between your two x-intercepts. So if I could go back up here to this parabola, if I know my x-intercepts, my vertex is always halfway in between them. So in this problem, if my zeros are at 4, 0, and 2, 0, halfway in between them is 3. X equals 3. I know my x-coordinate will occur when x equals 3. So I'm going to write my axis of symmetry, x equals 3 here. And then I need to now find my y value when x is 3. So I'm going to plug a 3 in for x, and I get 3 minus 4 times 3 minus 2. Looks like -1 times +1. So it looks like I would get a -1 for my y value. So 3, -1 would be my vertex. So I'm going to put a dot at 3, -1, my vertex. So this problem is really kind of set up to almost start to graph. It's really got part of my work done for me. The 1, 1 and 1, 1 is already done. So now I just have to do my 2, 4. So I go over 2 and up 4. 1, 2, 3, 4. And I go over 2, 1, 2, and up 4. 1, 2, 3, 4. And then I draw in my parabola for this problem, and I would get something like this. And my axis of symmetry is occurring at x equals 3, the y coordinate of my vertex. You can see how this parabola is a little wider than this one. The A being greater than 1 is making it more narrow. So you can see that in that particular graph. So let's try doing one more vertex form and one more factored form together so we make sure we understand that process. So coming back to page 2, we have the vertex form y equals -x plus 3 squared minus 4. So I can see my vertex here is -3, -4. The opposite of what I see in parentheses is my h, and then my k is just what I see. So my -1 here tells me that this guy is going to be reflected down or point down. So when I get ready to do my 1, 1 and 2, 4, I'll be moving my y values down. So let's graph our vertex, 1, 2, 3, and down 4, 1, 2, 3, 4. And now let's go ahead and graph our points on either side, right 1, down 1, left 1, down 1, right 2, 1, 2, down 4, 1, 2, 3, 4, and left 2, 1, 2, down 4, 1, 2, 3, 4. And we will draw in our x-intercept. I'm sorry, drawing our parabola. I don't know why I said that. Because the next thing I want to talk about is x-intercepts. But right now, I just want to finish this parabola. And this parabola is showing you something we haven't seen a lot yet. So in this graph, there are no x-intercepts. This does happen. It happens when my vertex is below the x-axis and my parabola faces down, or my vertex is above the x-axis and my parabola faces up. So this is an example of something we'll be looking into a little bit closer later. So now let's do one more factored form. I also have a -1 in front of this one, so we're practicing moving down with our movements. So we're going to start by finding our x-intercepts. This gives me an x-intercept at +2, 0 and -4, 0. So let's go plot those, -4, 0 and 2, 0. Once we have our x-intercepts, our next thought is to get our vertex. Our vertex, the x-coordinate is always halfway in between my x-intercepts. There is a distance of 6 between 2 and -4, 6 units. If I divide that in half, that means my vertex is 3 units away from each intercept. So 3 units from 2 would be -1. 3 units to the right of -4 would also be at -1. -1 is halfway in between my two x-intercepts. So my vertex has an x-coordinate of -1. To find my y-coordinate, I would substitute that back in. So y equals -1 or negative times -1 minus 2 times -1 plus 4. That's a negative or -1 if you want to write it that way, times -3 times 3. So it looks like what I'm getting here is -9 times a -1 or a +9. So my vertex occurs at -1, 9. So I'm going to go to -1 up 9 and plot my vertex. Sometimes kids, when they have these 3 points, will just go ahead and draw their parabola through them. I still like you guys to be very careful and get 5 good points. So I do think you need to take the time to do your 1, 1 and 2, 4. And in this case, my 1 and my 4 movements are negative. They're down. So over 1, down 1, to the right 1, down 1. Since I do say you need 5 points to graph, you could graph with these 5 points. Over 2, down 4, 1, 2, 3, 4. Over 2, down 4, 1, 2, 3, 4. Now I actually am graphing with 7 points, so this is a really accurate graph at this point. This would be the graph of this function. So at this time, ladies and gentlemen, in your groups, you're going to work through this packet doing more graphing. In this packet is mostly vertex form. So on this page, and please ignore the space on number 4. There was an A there. It's from my Math 2 class, and I wanted to take it out for your practice. So I whited it out. So these are all in vertex form. So you can find your vertex from the equation, and it says to graph the following with at least 3 precise points. I'd like you to use 5 precise points. That would be your 1, 1, 2, 4 movement included with your vertex. So then on the next page, you're actually given 4 graphs, and you have to write in the equation. So on these, and let A equal 1 for all graphs. There's actually one of these graphs where your A is not 1, but since we're not covering that right now, I'm not going to worry about it this time, and when we get to it, I'll come back and talk to you about it. So on these graphs, you need to find your vertex, and I think the best thing for you to do is try to write the equation in vertex form. That would be my y equals a times x minus h squared plus k. And so you will use your vertex. In this case, my vertex is at 0, 9. And I've told you the A is 1 for all graphs. So you know your A, you know your H, you know your K. You can write the equation, you know the vertex. Let's talk about domain and range. all these graphs, the parabolas should have arrows on the end. So the domain would be all real numbers because this parabola will very slowly grow outwards forever and ever. So all values of x from negative infinity all the way through to positive infinity, all values of x will be somewhere down here on my graph. So my domain would be negative infinity to infinity. The range is different. The range is your y-axis. Starting at the bottom of my y-axis, I notice that since my parabola points down, all these values of y are on my graph. They're actually on my graph twice until I get to y equals 9. That's my vertex, my maximum. This is a max right here. And so that is my very last y value. There's no y values after y equals 9. And so we would say that the range would go from negative infinity up to 9. And actually, I'm not sure in Math 1 in this curriculum if you guys have used brackets and parentheses. We'll talk about it on Thursday. This is a much easier way to write it and how most of your friends probably in Math 2, Math 3, and pre-calculus are doing it. But I think maybe you guys, sorry about that, you might be writing the domain as negative infinity is less than x, which is less than infinity. Some of you might even write that with all real numbers, which is fine with me. And then this guy, some of you might write that as negative infinity is less than y, which is less than or equal to 9. And others of you might just write y is less than or equal to 9, if I could cover that up, which is exactly the same thing mathematically. So again, sorry, I don't think in our class we've actually talked about writing it in interval notation yet, but we'll do that. If we haven't done it before June, we'll take a little time in June to do that so you're ready for it when you see it in another course. So on this page, you're going to be writing the equations, writing the vertex, and finding the domain and range of each parabola. And then when you get to this page, you have different equations. Some have an H, some don't. Some have a K, some don't. Some equations have both an H and a K. And so notice that some of them also have A values, which are negative. So you know the graph is going to point down. Some of them, your A value is positive 1, so the graph points up. Again, you're finding domain and range and vertex of those problems as well. Make sure you're checking these answers with the problems on the board to make sure that you're not doing anything incorrectly. I would hate for you to do it incorrect a number of times, and that would be a bad habit that we'd have to break. Thank you very much, and have fun.